Alright folks, so today we will be implementing a time unit converter in C++. So let's say that we're giving a time unit A, let's say milliseconds, and a value, let's say 1000, and another time unit B, so let's say seconds in this case, and we want to convert from milliseconds to seconds. So we get this value, which is represented in this time unit, and we want to output this in this time unit here, okay? So 1000 milliseconds actually corresponds to 1 second, right? So we want this output here from our program, okay? So it's a very simple definition of the program, okay? So how will we implement this in a convenient and clear way, right? So this is the help function that our user will require to know how to run the program. So if I go ahead and just run my code here, without giving any arguments, I will be prompted to give an input time unit, a value, and an output time unit, okay? And I explain to the user what unit codes he should use to run, to represent each time unit, okay? So this is a pretty simple output of a string, okay? So we have a string, we put this into lines, and we just output the string, okay? This is a very simple function. So let's move on to the actual implementation, and what is the basis of our time unit converter. So to make this simple for us, we use a basic time unit. So let's say in this case, let's use seconds, and we represent all the other time units, like we represent their ratio divided with this basic unit. So how many seconds does 1 millisecond contain? That's a question, okay? So if I divide milliseconds divided by seconds, what is the ratio that I get? The ratio that I get. So we know that 1 second corresponds to 1000 milliseconds. So dividing 1 by 1000 will give us milliseconds. The same goes for the other smaller time units. So for microseconds, we again divide by 1000, and for nanoseconds, we again divide by 1000. The same goes for greater time units. In this case, we do not divide, but we multiply. So we know that to get minutes, we just multiply 1 second by 60. So 60 seconds are contained into 1 minute. 60 minutes are contained into 1 hour, 24 hours into 1 day, and 7 days into 1 week. So this is a very straightforward map that you can create, which maps this given time unit into a long double value, which represents this ratio. A map, for people that are using Python, for example, is essentially like a dictionary that maps key to values, okay? So moving on, this is our basic function which we're using, which is, I'm just calling unitconf, and gets a string as the input, a long double value, and another string as an output, okay? So we gather two static variables here. So the input value will essentially be this ratio, okay, that we can get by using our string and our map here, which I'm calling time units, by the way. And the same goes for the output. So yeah, so just noticing here that if they are equal to 0, we're just returning -1 because we do not want to divide by 0. And if our value equals 0, then we cannot really convert it, like it's essentially 0, like it's 0 time equals 0 time, right? So what I'm doing here is very straightforward. So you can see that I'm dividing this ratio with the other ratio, okay? So let's explain how this works. So essentially, if you write this down as a mathematical equation, you have a value x, which is what the user gives, and a time unit a. Okay, let's symbolize this with a small a, and this equals to another value when we represent this value to the time unit b. So let's make this a small b just to represent this easily. So you have these two multiplications, and let's see what we know here. So we know that x is the value that the user gives, a is a ratio that I need, and b is actually, it's not the ratio, it's the basic time unit here, and b is the other basic time unit, okay? And what I need to find is this y here, okay? So if we solve this using basic math, we see that y equals x times a divided by b. So I already have this one, value x given by the user. So what I need is to compute this ratio here, so a divided by b. So let's take a sample case, okay? Let's say we have a equals to minutes and b equals to days, okay? So if I get the ratio, which is minutes divided by seconds, which I have in my key, as I have shown you before, so 60 in this case, and I get the other ratio that is days divided by seconds, which I also happen to have in my map here, I can use these two values to compute the ratio that I need, a divided by b, so minutes divided by days. Okay, and how I do this, I just divide these two ratios. So let's just solve this fast, just for you to see. So minutes divided by seconds, if I divide these by days, okay, days divided by seconds, you will see that this is multiplied with this is multiplied with this. So the two second values, they just go away, and I end up with minutes divided by days, which is the ratio that I need. Okay, so I'm using this basic map here to convert between any pair of time units. And after I have this ratio, I just multiply this ratio with my value here x, and I get my value y. So this is what I'm doing in this line here. I just multiply value by this resulting ratio. And you just have to notice here that I'm using long double here, just not to miss, like to conserve as many decimal points as possible as my computer can conserve in this long double data type, right? So I'm just then returning the long double value from my function. So let's look into the main function, which is essentially just to read the arguments from the user. So if the user doesn't give a qualified number of arguments, which is 4, so we have the name of the function, the name of the program, the input time unit, the value, and the output time unit. So this is 4 arguments essentially. So I'm just checking this. Otherwise, I'm printing help in the case that he does not input the correct amount of arguments. And then I'm using C++ strings to get the C strings essentially. So input unit, value, output unit, I set them to be empty at the beginning. So for the input unit, the same goes for the output unit. I just use a for loop here. So I start from the first character, which is indexed as 0, as we know. And I just move on until I meet the end of string character, this character here, okay? This is how C strings end with this character. So for every character, I just put this character in my C++ string now. I just add it in the back. So with these two for loops, very simple for loops, I'm just reading the input unit and the output unit here. So for the value, it's a little bit more elaborate implementation here. We just have a dot boolean, and that is to check that the user doesn't give 2 dots, for example. He just give 1 dot if he's going to use a decimal value. I go through the characters, I put them in my string. In the event that my characters is not in the range between 0 and 9, which is the characters that can represent numbers, right? I just check if it's a dot. If I have already met a dot, I just say that this is invalid because you have given 2 dots so far. Otherwise, I just set the dot to be true and I just move on. In the case that the character is not even a dot, then it's for sure an invalid value, right? So you cannot give like a D here or F or an exclamation mark, right? So that's just simple input checking. To call my function, I'm using the C++ strings, and I use this simple function that's provided in the C++ implementation in the libraries of C++, which is string essentially to long double. Okay, so given a string here, which is the value, I get the actual long double that this value represents. So if I give this number here, so 123.123, instead of having the string, I get a long double value for this number. Okay. So in the event that when I'm running my function, I get -1, which is only in the case that I have I'm preventing division by 0 essentially, or I have a 0 input value, I just output that it's invalid unit code, and yeah, I just return. In the case that value is valid, I just print the result of the function, and this is just the format. I'm using this precision to tell the output stream how many decimal digits I care about, and if I use this argument here fixed, I'm telling it to output all these decimal points. Okay, so let's go ahead and test this. So if let me just call my code here. So let's say I'm giving milliseconds, 1000 milliseconds, which was the basic example that we used here, and I want it to be in seconds. I will get these. I will get as many decimal points as I have set here. So I said 16 and a fixed. In the event that I remove this fixed and I compile, okay, you will see that I will not get all these decimal points because I did not explicitly told my output stream to output all these decimal points. So let's go ahead and do some conversions and just end the video. So let's say I have weeks, like let's say we have weeks. So we have 10 weeks, and we want them to be represented in nanoseconds. So it will be a lot of nanoseconds, right? So that's the number we get. Let's make it even more interesting. Let's say 1000 weeks into nanoseconds, which is the smallest time unit that we're using. So as you can see, you get the number and the exponential notation at the end. If we cannot represent it just with enough digits here, right? So that's pretty much it, guys. Leave a comment if you have any question. Like the video if you did, and subscribe to the channel. So I will be making more of these videos. See you in the next one.